Chapter 7, Part 1, Work. Now the word work is used in our daily life. We say, I work, I go to work, I will be working on my homework, I hate my work, and so on. However, the word work has a specific meaning in physics. In physics, work is done by a force acting on an object and moving it a distance. In this case, we say the force is doing work. So work is done by a force. Work involves force and distance. Mathematically, we write work is equal to force times distance. So, for work to be done, we need a force and a movement of an object under the influence of that force. This is an example. So people pushing a car, there is a force, and that's the push by the people. The object is the car, and as the car undergoes a distance, we say that the force is doing work. The unit for work combines a unit of force, that's Newton, with a unit of distance, meter. So the unit of work is Newton times meter, which is called joule. 1 joule of work is done when a force of 1 Newton acting on an object and moving it a distance of 1 meter. We have a question here. If you push against a stationary wall for several minutes, you do no work. On the wall, at all, both of the above, none of the above. Well, if you push against a wall for several minutes, you are doing no work on the wall because the wall is not moving. We said that to do work, we need a force and distance. So the answer is A. There is no work on the wall. If we lift two objects, we are doing twice as much work as lifting one load the same distance. Because in this case, the force is twice as great. So, if the force doubles, this means the work will double. If we lift one load twice as far, so we are doubling the distance, so in this case, work will be also twice as great. Because as you double distance, also work will double. In this example, work is done in lifting the barbell. If the barbell could be lifted twice as high, then the weightlifter, would have to do twice as much work. Here, there's an important point to clarify. While the weightlifter is holding a barbell over his head, he may get tired, very tired. But he does no work on the barbell because he's holding the barbell. He's not moving it. So he's doing no work on the barbell. So you may wonder now why the weightlifter is feeling tired. Now it's true that the weightlifter is doing no work on the barbell. However, he is doing some work on his muscles by stretching and squeezing them. So there is work, but the work is not done on the barbell, it is done on the muscles. And that's why the weightlifter will feel tired. When the weightlifter moves the barbell, he is doing work on the barbell. Question. You do work when pushing a cart with a constant force. Now, if you push the cart twice as far, then the work you do is Which one is the correct answer? Well, it's clear that as you push the cart twice as far, so you double the distance, then work will also be twice as much. So the answer is B. Now, as we are applying or doing work on objects, you can do work to change the speed of an object. For example, you bringing an automobile, a car, to a speed, or slowing it down. That means we are involving work. In both cases, work involves a transfer of energy between an object and its surrounding. When you push an object, it will accelerate, which means its speed will increase. So it will become faster. So by doing work, you could increase the speed of an object, or you could slow it down. And that's what it meant in this slide. Question. Suppose that you apply a 60 Newton horizontal force to a 32 kilogram package by pushing it 4 meters across the floor. How much work do you do on the package? Now, to answer this, we already know the force and we know the distance. So work is equal force multiplied by distance, and the answer should be 240 joules.